Welcome to the Journey Shake Cam. Today's warm-up, number 1, is all about Dalton's Law. And you just don't worry about going any further. You just have to find the pressure of that dry gas. And then number 2 would be normal. Do the best you can, and I'll see you in a moment. In number 1, we are using Dalton's Law. And Dalton's Law is that the pressure of the dry gas is equal to the pressure of the total minus the pressure of the water. And this is what we will be using in each case. Now, in the first one, we are given kPa, and so we had to just look on the sheet that has the various pressures for water at different temperatures. And when you think about it, what would the pressure be of water when it's boiling? Well, it would be the same as the surrounding pressure. And normally, if you were at sea level, that would be 101.3 kPa. However, at this temperature, it is 5.6 kPa. And therefore, when we subtract the pressure of the water from the total pressure, we get 94.4. And then I follow my significant digit rules, and my final answer there would be 94 kPa. And this was the vapor pressure of the water at 35 degrees Celsius. In the second case, now we're given 750 torr. And because our units in our chart are in kPa, we must make a conversion. And therefore, when I convert, it's just like any other conversion. What I'm looking for is kPa. What I want to cancel is torr. Therefore, there are 101.3 kPa for every 760 torr. And when I do the math, I get 99.9671 kPa. And then the temperature that I'm given, I'm going to have to also figure out the midpoint in there. And that temperature was 75 degrees Celsius. And so the pressure for water at 70 degrees was 31.2. And for 80, it was 47.3. I divided by 2 to get the midpoint. And that's 39.25, which I subtract from my total pressure. And I get this number, and then I round to 2 significant digits as given in my problem. And I'll be right back. Now, in 1C, we are changing atmospheres to kPa because our pressure of the water is in kPa. And in 1 atmosphere, we have 101.3 kPa. And I change that value to kPa. And I like to have my units. And then I have to subtract the pressure of the water. Well, this one was very straightforward. It was just 2.6 kPa at 22 degrees Celsius. And when I do the math, I get 149.3500. I look back to my original problem, and I need 2 significant digits. And therefore, my answer is 150 kPa. And that's how you do those Dalton's Law problems. In number 2, we fill in the chart of the variables. My initial volume is 50 milliliters. My initial pressure is 3 atmospheres. My initial temperature is 55 degrees Celsius, which I must change to Kelvin, which is 328 Kelvin. My V2 is my unknown. My P2 is 7 atmospheres, and my T2 is 75 degrees Celsius, which is 348 Kelvin. Now, because I have volume, pressure, and temperature, I have the combined gas law, which is V1P1 over T1 equals V2P2 over T2. It's almost like a song. Yes. And now, therefore, V2 equals V1P1 T2 divided by T1 P2. Substituting in the values, I have 50 milliliters times 3 atmospheres, 348 Kelvin, divided by 328 Kelvin and 7 atmospheres. And notice I always follow through with my units, so I see exactly what I have and what cancels. And when I do the math, I get 22.7351. I go back to my original problem and I see that I need 2 significant digits in my answer, and therefore that would be 23 milliliters. However, of course, we're not quite done. We have to make a conversion, and it's always good to practice conversions because you will see them on the assessment. And I need to change my milliliters to centimeters cubed. 1 centimeter cubed is 1 milliliter. And then I'm changing to decimeters cubed. Again, there are 10 centimeters is equal to 1 decimeter. When I cube 10, I get 1,000 centimeters cubed is equal to 1 decimeter cubed. And therefore, my final answer is 0.023 decimeters cubed. And that's how you do number 2. And I want to tell you a little bit about the quiz that you will have tomorrow. There are 5 problems, and you will need to identify which law that you are using in those problems. And each problem is worth 20 points, and identifying what law you're using is 5 of those 20 points. There will be a little bit of conversions, and you need to be able to rearrange your equation for your unknown. And normally students do very, very well on this quiz. And I'm sure that you will too. So that's what you can expect for tomorrow. And I can't wait to see you then. Bye.